This video is about the conjugate of binomials. We'll talk about what a conjugate is and one of the many applications of how they're useful. Let's get started. The conjugate of the binomial a plus b is a minus b. You have the exact same first term and the exact same last term, and the sign in the middle is different. Okay, that's what a conjugate is. And there are some things about conjugates that become very helpful for us in certain applications. Okay, so we'll do one or two of these to find the product of the conjugate radicals. Okay, these are radical conjugates, but there are also complex conjugates that we'll talk about later on. The idea of the conjugate is the exact same. The first term is the same, the last term is the same, and that middle sign is switched. And we'll talk really quickly here about why that's useful. Okay, so if I multiply these binomials together, which, by the way, these are conjugates of each other. If I multiply these together, root 5 times root 5 is root 25. Root 5 times negative root 3 is a negative root 5 times 3 is 15. You can multiply numbers inside radicals together, multiply numbers outside of radicals together, but you don't really mix them without doing a simplification process. The other two, root 3 times root 5 is a positive root 15. And then root 3 times negative root 3, let's see here, a positive times a negative is a negative root 3 times 3 is 9. Now, notice that because we have that same first term, same last term switching signs, that this middle term and this middle term will both cancel out. And that happens every single time we have conjugates, okay? Which is actually at the heart or the root of why they're so useful. Okay, so root 25 is a perfect square because I had root 5 and root 5. The square root of 25 is equal to 5. And then I have this minus that's right here. The square root of 9, 9's a perfect square because it came from 3 times 3. And so the square root of 9 is 3. And so 5 minus 3 is the number 2. Okay, so something about conjugates and that middle term canceling out, and we will frequently get rid of radicals. Okay, so they're very helpful for us in that way because that middle term cancels, we get perfect squares, and we get whole numbers in the end of that. So if we want to get rid of radicals, something about the conjugate is really useful for us. Let's try one more just to see how it works. Okay, 7 times 7, again, multiplying whole numbers together, just like we're used to. 7 times 7 is 49. 7 times negative root 2, again, you multiply radicals together, the numbers inside radicals together, numbers outside radicals together, but you don't really mix them without simplifying. So this actually becomes just a minus 7 root 2. Okay? And then a positive root 2 times 7 becomes plus 7 root 2. And root 2 times negative root 2, a positive times a negative is a negative. Square root of 2 times 2 is 4. Okay, so again, we have that middle term because of the conjugates, same first term, same last term, switching of signs, we have a canceling of these two middle terms. Okay, and so 49 stays 49. Okay, and then minus the square root of 4. Let's see here, 4 is a perfect square. So the square root of 4 is 2, and 49 minus 2 is 47, and that is what that's equal to. So something about this conjugate is useful for us to get rid of radicals. Now, there are, again, several applications of this. One of them we'll see down below. We frequently want to write or be able to write fractions with rational denominators, okay, and not have a square root in the denominator. So if we have a fraction of root 3 over 5 minus 2 root 3, Okay. If we want to write that so we have a whole number in the denominator, okay, or a rational number in the denominator, then we'll need to use a conjugate. So we'll multiply top and bottom by the conjugate of the denominator. So multiply this times 5 plus 2 root 3 to use that the power of the conjugate, but that would change the value of the fraction, which we can't do. So I'll multiply top and bottom by 5 plus 2 root 3. So this right here, by the way, this is a fancy version of the number 1 because I have the same thing on top, the same thing on bottom. Multiplying by the number 1 won't change the value. Okay, so doing this right here is changing how it looks, but it will not change the value of this fraction. Okay, so let me kind of just point that out and we'll keep going. So it's times 1, so I'm not changing the value of the fraction, but it will get rid of some radicals in the denominator. So let's multiply on the top. So I'm going to distribute root 3 times 5, and that's root 15. Root 3 times 2 root 3. Let's see here. I can multiply the numbers together, so I get plus 2. And then the radicals together, root 3 times root 3 is root 9. Okay, there's still more to do that, I'll do the bottom next. 5 times 5 is 25. 5 times 2 root 3, I'll multiply the whole numbers together and get positive 10. And then the radical, nothing there, times root 3 is root 3. And then this other term, negative 2 root 3 times 5 is negative 10, the whole numbers together, and then the root 3. And then a negative times a positive is a negative. I'll multiply the whole numbers together. 2 times 2 is 4. And multiply the radicals together. Root 3 times root 3 is root 9. Okay, I got to keep going a little bit further. Let me look at how to simplify this. Now, with the conjugate, again, that middle term cancels out. That should not be surprising by this point. Let's keep going. So I have root 15, and let's see here, plus 2 times, now this right here, root 9 is equal to 3. So 2 times 3 is 6. Okay, and I have 25 minus 4 times, let's see here, this is also going to be 3. 4 times 3 is 12, so I get 25 minus 12. And so my final answer is root 15 plus 6 divided by 25 minus 12 is 13. Okay, now it may not look any simpler than what it started with, but I do not have any square roots in the denominator, which is simplest radical form. Okay, so again, this is just one of several applications of how the conjugate is useful for us, but it is an important tool to be aware of as we try to get rid of square roots and things like that. So this video is about conjugates, what they are, and one of the applications for how it's useful. Thank you so much for watching.